model with cardboard. That's like the triangles as they standing up. So I'll see if I can manage that this week. I haven't ever tried to do that before, but I think it could be helpful. Are there any questions on this one, guys? Okay, question 7 was quite interesting. I'm just going to show you the diagram quickly. This was the picture. This was from the May, June exam. So this was the picture that they gave us. They told us that ABC is a rectangle. So guys, remember if they tell us that you can use all the properties of a rectangle. Okay, so you can use the fact that the opposite sides are parallel, that the opposite sides are equal. You can use the fact that all those angles are 90 degrees. Okay, then they gave us this bottom triangle, the horizontal triangle. So this rectangle is standing up, right? Then we have a triangle that's also standing up. And from this point of the rectangle to the base of the triangle, we have another triangle on the graph. So they gave us some information there. First, they wanted us to write CD, which is this side, in terms of, or they wanted us to prove that CD was BC over 4 cos squared x, right? Now, guys, because they've used BC, I'm just going to show you. Okay, because they wanted us to prove that. We're using BC in the proof, right? You have to actually use BC in your calculation. Usually they'll give this like another name, like a K or a D or something, and you can then work with K or D. This time you have to actually work with BC. Now guys, again, what we always do is we find the common side, right, between the two triangles. So we have a triangle here at the bottom. We have that triangle over there. CD is a side in the upright triangle. Okay, so I'm going to work in my green triangle, my shaded triangle, to get the common side, which is CD, and then use that common side here at the top in my upright triangle to get an expression for CD. Okay, so always from the triangle with the most information, we get the common side, then we work in the other triangle using that common side. Okay, so what I did was, I said in this bottom triangle, CE over sine of 30 degrees, right? I have CE, or I'm looking for CE, sorry, that's the common side. I have the angle opposite. But because they told me that BC must be in my answer, I'm going to work with BC over sine of the opposite angle. Right, so I actually had enough information in this bottom triangle, this horizontal triangle, to use sine rule straight away. All right, so that's what I did there. CE over sine of the opposite angle, is equal to BC over sine of the opposite angle. Then I did some manipulation after that, just to get my BC actually a bit simpler, or my CE, a bit simpler, the common side there. I moved sine 50 over the side. We know that sine 50 is on x, right? So that's where that part comes from. It's sine 50 that I moved across and I calculated it. I don't think this question said that you weren't allowed to use a calculator, so you didn't actually have to show your special triangle there. Sine 2x, I changed that straight away to 2 sine x cos x. All right, guys, if you don't know what to do, at least change your sine 2x to 2 sine x cos x. You'll get a mark for using that identity. Okay. Then from there, because I now have a compound fraction, right, and you see that happens quite a lot in this work. We have a fraction within a fraction. You multiply the top and the bottom by the denominator of that fraction, thank you, to get rid of it. Okay, so I multiply the top and the bottom by 2, because a half times 2 is just 1. Okay, so I'll be left with just BC at the top. And here we already have a 2. When I now multiply that by 2, I get 4. Okay, so this is the common side, guys. Now that we have an expression for the common side that has BC in it, right? We know we're on the right track. We then can work in this upright triangle, which is a right angle triangle, so that we can work with sine cos x. So then again, I just look at the angle that they gave me. They gave me x. I am looking for the opposite side, right? CD, that's what they're asking us for, and I have an expression for the adjacent side. The opposite and adjacent is tan. So that's what's happening there. Tan x is opposite over adjacent, CD over CE. Remember, we're trying to find CD, so I just multiply CE on the other side. And then after that, we just have to take this expression for CE, sub it in there. You have to change tan to sine over cos, and then it actually works out quite nicely. Right, so you have your BC at the top, you have your 4, the sine x at the bottom, cancelled out with that sine x there, and then that cos squared. Any questions on that one? Okay, 7.2, I did do on the next page, but I did redraw the diagram. All right, so for 7.2 now, I just filled in there that we know that CD is now that, BC over 4 cos squared x. They're now telling us in 7.2 that x is 30 degrees. All right, so if x is 30, then this is 60, and that is 30 degrees. Okay, you might have to use that, maybe not. The question was saying we now need to show that the area of the rectangle is equal to 3AB squared. Right? 3AB squared. So what I did was I just wrote an expression. I just said to myself, okay, we want to find the area of the rectangle. It's going to be length times breadth, right? We all know that. Area of the rectangle is length times breadth. So I just used BC and CD. Okay, but we can replace CD with AB if we wanted to, because it's a rectangle, right? That's why I got you to together. So what I did was I used the expression that we got in 7.1 for CD. We proved in CD, in 7.1, sorry, that CD is equal to this, right? But now they're telling us that x is 30 degrees. So cos of 30 is root 3 over 2. So cos squared of 30 is root 3 over 2 squared. Right? So if you simplify that, you can actually get that CD is BC over 3. Does that make sense to you guys? Root 3 squared is 3, and 2 squared is 4. Right? So this is actually, if we wanted to put in an extra step, 4 times 3 over 4. Right, sorry, but you see what I'm saying? Right, if you square that, and you then times it by 4, the 4s are going to cancel out, so you're left with 3 over 1. Now guys, if you're looking at this, right, CD is equal to BC over 3. I can make BC the subject by just moving that 3 over, right? I basically just did that because I prefer to not work with fractions. Okay, but it did actually help us in the long run, because CD is equal to AB if we're looking at this rectangle, right? CD and AB are equal. So we can actually say that BC is 3 times AB. Does that make sense? The CD and AB are equal, right? It's a rectangle. So then if you're finding the area of this rectangle, you can say that it is BC times AB. So whatever we just got for BC, 3AB times AB. Right, so the area of ABCD is AB, that's the breadth, multiplied by the length, which I just calculated up there. And then I actually did that off. So guys, it looks to me like in the matric final exams, it's usually the first question is kind of doable if you use the method that we've always done, right? Finding the common side in the triangle with the most information and then using that in the other triangle. But then the second question often is quite critical, right? There's some other things going on here. Okay, I think I'm not going to mark the last one now because judging by your facial expressions and your lack of any movement, it doesn't look like you guys did this. All right, so we'll mark it at some other stage as we are starting calculus today. So please make a new reading. Yeah, okay, all right. One at a time. So can you give it a key? Can you guys just do that? That's what you guys want to do. Okay, so just Yeah, make a note of the yeah. Okay, calculus, thank you. Make it headed, please. I'm not going to write what chapter it is. There's a bunch of different chapters. Yeah, thank you. All right, so let me just get this textbook. Guys, did any of you by any chance borrow my textbook at some point and they never give it back? I won't be upset with you guys. I just really need my book. I'm using Edgar's book at the moment. Thank you for allowing that. But if you can maybe just check if the book that you have is actually your book, and if it's mine, then I would love it back. Yeah, I know. I'll say next time. You didn't even try out of the book. Okay, no problem. All right, guys. Now, calculus is a very big topic. It has lots of subtopics, and it's a bit difficult to just kind of jump into it. I first need to teach you a few basics. All right, so I first need to teach you about gradient and average gradient. And then I'm going to have to teach you how to factorize cubic equations and the complement work, and then we're going to put it all together. Okay, so for the first bit, it's going to seem a bit disjointed. It's going to look like we're doing like separate topics, but it's just because I need to teach you how to do certain things before we put it all together. Okay, so just bear with me for the first couple of lessons. Let me just check that. I lost my place now. All right, guys, calculus is basically the study of change, which again is a very broad topic. But if you want to, you can make a note of that on the side of your heading. Calculus has to do with change. And we are going to keep referring back to graphs and gradient specifically. All right, gradient is quite a big thing in calculus. Now today we're going to be talking about gradient and average gradient specifically. So that is the first heading. If you want to make that would be like a bubble or a cloud heading. Now guys, up until this point, we've only worked with gradient of a straight line. Right? If you thinking of when we did functions and even when you did analytical geometry, we have worked with gradients of a straight line. All right, so I'm going to write that down. The first, sorry. The first thing was gradient of a straight line. And do we remember that formula? I'm sure we do. What is it? Does someone want to say it? The formula for gradient? Yes, good. Change in y over change in x. Okay, so if you have, I'll just do an example actually while we're talking about it. If you have, for example, a point that's going from A, we'll make some coordinates up here, let's say 1, -3, and the point B is -2 and 6. And they then ask you to find the gradient of line AB. All right, so if you want the gradient of AB, remember for gradient, the lowercase m always. And if you want to say that it's the gradient of a specific line, then we just use that as a subscript. So the gradient of AB is then I'm going to write here change in y over change in x. But you obviously don't have to write that every time you're calculating it. You can just calculate it actually. You don't have to write the formula. You can also use delta, right? You can also use like that triangle with a y or the triangle x. So now guys, you can decide which point coordinates you want to start with. So let's say we're going to start with the coordinates of A, just because we're taking first. It really doesn't matter. But we're going to take the y value of A minus the y value of B. All right, so we're going to say the y value of A is -3 minus the y value of B, which is 6. Over, now if we started with the y value of A, we also have to start with the x value of A. And you have to use the same coordinate in the first part always. So now we're going to take the x value of A, which is 1, minus the y value of B, which is now -2. Okay, so you would have to say minus -2, or you can add 1 plus 2 if you want, that's just fine. Now from here, you can decide to type that into the calculator and write your answer, but often it's something that we can just calculate ourselves, right? -3 minus 6 is -9. Over, this is 3. What's -9 divided by 3? -3. Okay, so the gradient of this line is -3. That was very fast. All right, so that's the gradient of the line, right? Now, this year we're going to actually start calculating gradients of curves as well. And that's a bit tricky because if we are to try to choose the gradient of a curve, missed the bus on the there you go. All right, so gradient of a curve. Now guys, the reason why we just use one formula for the gradient of a straight line is because if we have a straight line, right, let's say this one, for example, this is a negative gradient. So a straight line just has the same gradient everywhere. All right, if you take any 2 points on that line, there are an infinite number of points on that line, right? You can identify any 2 points on that line. If you use those 2 points in the gradient formula, you will get the same gradient between any 2 points on that line, all right? If it's a straight line. But what happens with a curve? Let's take, for example, a parabola. All right, just a very rough sketch of the parabola. We're going to put it on Cartesian plane. Now, guys, if I take, for example, get a different color here. If I take that point there and that point there, right, and I draw a line between those 2 points, and I calculate the gradient between those 2 points, will that be a negative gradient or a positive gradient? We're looking at the shape. If we were to actually draw a straight line through those 2 points, would that straight line have a negative gradient or positive gradient? Negative, okay? So on this side, the gradient will be negative. If you choose any 2 points on this side of the parabola, right, and find the gradient between those points, the gradient would be negative. But now, if I choose a point there and there, right, on the other side of the parabola, and I now draw a straight line through those 2 points, will that gradient be positive or negative? Positive, right? Can you see that? That's if you actually draw a straight line there. The gradient will be positive. What if you take this point here, the turning point of the parabola, and you draw a straight line there? I'm actually going to do that, right, because that would be easy to do. You draw a straight line there, just touching that turning point. What do you guys think the gradient will be at that point? 0, hey? What do we have here? This kind of line is a y equals something line, right? If you have to actually write the equation of this line, this will be a line of like y equals 3 or whatever. Okay, so the turning point is at 3, that will be at y equals 3. So guys, what you do is you'll change in y, right? You're going to have a y value of 3 minus a y value of 3 always. Okay, you're going to have a gradient of 0 for that specific line. I don't know if you'll be able to read this now, but I'm writing there that gradient is equal to 0. Sorry, that color is a bit light. Okay, but at that point, you're going to have a gradient of 0 always. So now what I'm trying to make you see is that on a curve, you are not always going to have the same gradient at any 2 points on that curve. Right? On a straight line, you always have the same gradient at any 2 points on that line. But on a curve, depending on the 2 points that you're choosing, you're going to have different gradients. Okay, and that is what we call the average gradient. So whenever you're working with a curve, right, and they give you 2 points on that curve, and they ask for the average gradient, you're going to use the same formula. You're going to use the same change in y over change in x, but it just has a different name. Okay, because it's not the same gradient everywhere. So let's do an example quickly so that you guys can see what I mean. Let me just find one here. That's a nice example. Yeah, it's just that. Sorry guys, let me just look for an example here. This exercise is not nice at all. Okay. All right, let's say for example, they have like a table here and they have a parabola. Like that. Sorry, I wasn't able to check the textbook before because I don't know where mine is. Okay, let me just check this. Okay, here's an example. All right, guys, I'm going to move down. Are you all done copying down that first bit, number 1? Okay. I'm going to do the example underneath this diagram, but you can do it on the side if you have space. I'm just going to write your example. Let f of x be equal to x squared. All right, so that is saying we haven't worked with function notation in a, actually we did, right? We worked with functions as the second topic of this year. So this is basically just saying y is equal to x squared. Now they want us to find the average gradient of f between the points with x equals -3 and x equals -1. So guys, what type of graph is this? Y equals x squared. Parabola, right? Okay, so let's just write that down. It is a parabola. That is why they're asking for the average gradient, okay, because it is a curve. Yes. Yes, they can, yeah. So guys, to find gradient for Alice gradient, it's the same formula, okay? It's going to be changing y over changing x. We need 2 points. Do we have 2 points at the moment? We have 2 x values and 2 y values. We just have 2 x values, right? Can I use those x values to find y values on the graph? I have the equation of the graph. Okay, so before I can actually find the gradient, I need to find those 2 coordinates, those 2 points. So when x is equal to -3, we're going to have to use the equation of the graph to find the y value at that point. So when x is -3, y is going to be equal to x squared, -3 squared. And what is that? 9. There we go. All right, so one of our points is the point -3 and 9. When x is -1, so that's the other x value that they've given us, y is going to be x squared, so -1 squared, and that is just 1. So the other point that we have is -1 and 1. So now, guys, it's just like when we calculated the gradient at the top, all right? In that first example of the straight line. But now when you're actually doing your calculation, guys, you have to write average gradient. 55 is like A, B, E, but just for this first example, let's write it out properly. Average gradient. Again, change in y over change in x, which we're doing here. Okay? So let's take the first y value, 9, minus the second y value, 1. 9 minus 1. Over. First x value minus second x value. -3 minus -1, please. Guys, what am I going to get at the top? What's 9 minus 1? 8. And at the bottom, I have -3 plus 1, which is -2. What's 8 divided by -2? -4. Okay, and that is the average gradient of the curve between those 2 points. They can give us any other 2 points and the gradient will be different. Okay. That's the first bit, the first thing that you need to know. Are there any questions at this point, guys? Anything you want me just to explain again quickly? Yes, but the thing is, it's not the gradient of the whole curve. It's just the gradient of the curve between those 2 points. If they had given us 2 other points, the gradient would be different. But yes, we are just calculating the gradient between. Yes, correct. Yes. A gradient first right with a line here. So certain vertical and horizontal. Yes, so how is that a constant curve? Or is it just a gradient? Yeah, it's actually calculating the gradient of the line those 2 points on the curve. Yes, yeah. So we are going to talk much more about that whole concept. But yes, it is basically. Okay, guys, any questions or any other questions up until this point? Okay. All right, now we are going to learn how to factorize cubics. Factorizing cubics, that is the next heading, please. Again, like I said, it seems very far removed from what we just did. It is something completely different, okay? We just need to cover all the basics. I've no idea. Sorry. I don't know how many examples we'll do. We'll have to do as many as we can. I hope everyone understands. Okay, so factorizing cubic expressions. Say again? Something. I don't know what that is. Who does this something thing with you? What's that? Back to here. Oh, I see. Oh, so is that what you're saying? No, it's not exactly that. If it is a somewhat different to yes, but it's not always going to be. So yeah, I actually wasn't going to go over that, but let's go over that again quickly. Guys, in grade 10, you you learned how to factorize, so let's say factorizing the sum or difference of two cubes. So we'll just do an example of each. If you had, for example, x cubed plus y. Let me rather not, sorry, have you written that down already? Let's rather do x cubed plus 8, sorry. This was something that you learned in, yeah, it was in grade 10 already, and then it doesn't really come up again after that, up until this point, really. This method you can only use though if you only have two terms and both of those terms are cubes. Alright, remember a cube is something that has a cube root. Okay, so x cubed definitely has a cube root. The cube root of x cubed is just x. And 8 also has a cube root. What is that? 2. Alright, so if you recognize that, if you see that you have an expression of only two terms and it can be a plus or minus, we'll do an example now of a minus, and both of them are cubes, then what you're going to do is you're going to end up with two brackets. The first bracket is going to be a binomial and the second bracket is going to be a trinomial. So for your binomial, you're going to take the cube root of each of these terms. So the cube root of x cubed is x. And the cube root of positive 8 is positive 2. Right, that is how you get your first bracket, your binomial, the cube roots of each of those. Then you use your binomial bracket to set up the trinomial. So firstly, you're going to take x, you're going to square it. Okay, that's x squared. And that should make sense, right? Because if we were to multiply these brackets out, I was going to get the same thing here. So what must you multiply x by to get x cubed? X squared. Okay, so that's where that comes from. If we're looking at the last term, what must I multiply 2 by to get 8? 4. All right, but the shortcut that we were taught in grade 10 was saying that you take this number, the second term in your binomial, and you square it. Okay, but you can also look at it in the sense of what must I multiply 2 by to get 8? It's 4. Now we need a middle term, guys. Now the middle term is always going to be, if you multiply these two terms together, what's that? What's x times positive 2? 2x. But then you have to change the sign. All right, so it has to be minus 2x. And the reason for that having a different sign is so that all the in-between terms can cancel out. Okay, because here, we're not going to have an x squared term, we're not going to have an x term. All right, we just have the x cubed, and we have the 8. The only way for all those middle terms to cancel out is if that sign is different. Okay, it's the same if you are doing a difference of two cubes. So let's do a different example. If you have, okay, if you have 8x cubed minus 64 goes into 125. Let's do that. Yeah, I couldn't think of a cube now, guys. Wow. Okay, 8x cubed minus 125, right? Both of those terms are cubes. They have cube roots. What is the cube root of 8x cubed? 2x. What is the cube root of negative 125? Negative 5. So the sign in the binomial is always the same as the sign in between your terms. All right. Now, let's look at it this way because we are actually going to use this method when we're doing the other cubes now. What must I multiply 2x by to get 8x cubed? 4x squared, right? And 4x squared, guys, is also what you get when you square this first term. You get 4x squared. Let's do the middle term quickly. If we multiply these two terms together, we're going to get negative 10x. But then we have to change that sign to plus 10x. And now what must I multiply negative 5 by to get negative 125? Positive 25. Or you can just look at it or add it as, so I'll take the negative 5 and square it, which is positive 5. Okay, so those are very specific cubic expressions, all right, which you need to use a very specific way of solving for. So now I'm going to show you how to factorize other cubic expressions. So factorizing. So now I just need to look for some that actually factorize nicely. I don't want to. You can use it for one part of it, not for the whole thing. Sorry, I'm just looking for a nice one to start off with. Okay, let's do this one. X cubed plus okay, that's the first one, guys. X cubed plus 9x squared plus 26x plus 24. Now the fact that, thank you, the fact that the highest exponent of x now is 3, right, that makes it a cubic expression. We are used to doing quadratic expressions, which is an x squared, right? Now guys, when we are factorizing, or when we are, can we actually make this equal to 0? That will be a bit easier to use, I think. Right, let's just make that equal to 0. Now guys, remember when we're solving a quadratic equation, right, we always have to get everything on one side equal to 0 and then factorize what we have on the left. All right, we're going to do the same thing here. The same concept for cubic equation or expression. We'll get everything on the one side equal to 0 as well. Now we need to factorize what's on the left. Now guys, when we are solving for x here, right, we actually have to find the value for x. We need to find a value for x that if I sub it in to all these x's in this equation, it will make it equal to 0. Right? Does that make sense? When we're solving for x, we're trying to find a value for x that makes the equation true. Right? So any number for x that if I cube it and then say, and then I multiply by 9 after I've squared it, then multiply by 26 and then add 24 will give me 0. So what we're going to have to do whenever we're solving cubic equations or factorizing cubic expressions is we need to get our calculators out, please. We're going to do some trial and error to start off with. And unfortunately, that is the only way to do it. So let me just get mine. We are now going to look for an x value that if I sum it in, makes that whole thing equal to 0. We can use the equation function, but let's not for now. Okay, so guys, are we ready? We're literally going to take x values. All right, let's start with the most obvious one. Let's start with 1. Okay, so let's write here. Is x equals 1. All right, that's the first one that we're going to test. Guys, we're literally going to take the calculator, we're going to type this equation in, and in the place, thank you, in the place of x, we're going to put in a 1. All right, so let's all do that. And don't clear the calculator after you've done that, please, guys. Just leave it as it is. Okay, you're typing that whole equation in. And in the place of x, you're putting 1. It's equals, that's 60. Is that what I have on the right-hand side of this equation? No. All right, so this is not going to work. X equals 1. Now, the next one that I always test is x equals -1. You obviously don't have to write down this whole testing thing, but just as the first example, let's write it down. Guys, use your arrow button and just go change all the positive ones to -1. Okay, let's save time there. So don't clear the whole thing and type everything in again from the start. Use your arrow button and just insert a minus there in front of all of those ones. What do we get? 6. All right, so that's not going to work. We want 0. Next up, you can now do 2 and -2. Maybe you want to do -2 first because the minuses are already in there. But you can decide, right? You can do 2 first if you want. There we go. Right, when x is -2, the equation is equal to 0. So that is the first solution of this equation. I'm just going to write here. Trial and error until you get 0. So guys, the first value of x, the first answer for x here that works, that makes the equation true, that makes the equation equal to 0 is -2. But I can't just write that, right? I have to actually put that in a bracket. If I'm supposed to calculate this whole thing, I'm supposed to have brackets. Now, what does I have in a bracket for the answer of that bracket to be equal to -2? What does that bracket actually be? X plus 2, hey? So I'm going to have x plus 2 in a bracket, and then I must put my second bracket after that. All right, we'll talk about that now. That's the difficult part of this work. Getting the second bracket. So guys, first you identify what the value is, the answer for x, the first answer. And you might get different ones, right? Sometimes people start by trying out like 6, and maybe 6 will also work, then your first bracket will be different. That's okay. All right, you look for a value for x, or value out of x, that will make your equation actually equal to 0. That then gives you your first bracket. And guys, this is coming from the whole thing. We're going to get another bracket now and make it equal to 0. Don't write this in here. But then remember, when you have 2 brackets equal to 0, you take the one bracket, make it equal to 0, and then the other bracket, make it equal to 0. All right? Oh, yes, yeah. But I'm just thinking of like a normal trinomial factorize. But yeah. Why? Because that's what I'm trying to say here. If you have a bracket multiplied by another bracket, you'll say, okay, the first bracket must be equal to 0, right? To make both of your brackets equal to 0. Remember, when you're solving. So then x will be -2 from it. Okay, so if you have your x value in the bracket, it's always going to have a different sign. Okay, I'm just going to erase this, guys. You can write this down later. All right, are we okay with that first bracket, guys? You start with x value, you get one that makes your equation equal to 0, and then you put that x value in your bracket. Now, the second bracket is where things become a bit tricky. Okay, it's similar to what I did up here when I said, what if I multiply 2xy to get 8x cubed? Same thing as what we have to multiply by 4x squared. We're going to do the same thing here, guys. What must I multiply x by to get x cubed? X squared. Okay. Now it's again easy to do the last term first before we look at the middle term. What were my last terms here? 2 and 24. What must I multiply 2 by to get 24? 12. Right, so we check. What must I multiply my first bracket by to get the actual expression? Now, guys, the middle term is the difficult part, okay? You can decide to either look at the x squared terms or the x term. All right, what works for one will work for the other. I'll show you now. So I'm going to look at 9x squared. I need to get, when I multiply my two brackets out, I need to get 9x squared as an answer, all right, as one of the terms in my expression. Now, what product here, when I multiply a term in my first bracket by a term in my second bracket, will give me an x squared as an answer. If I take 2 and x squared, that will give me x squared, right? What am I going to get if I do that? 2 times x squared is 2x squared. What do I need? So I need in the end 9x squared, right? I have 2x squared. I need another 7x squared. So guys, you are going to put in plus 7x because that is going to give you your 7x squared. All right, your first term in your binomial multiplied by your middle term in your trinomial will give you the other x squared when you actually multiply that. Now, I know it is difficult. Don't stress if you feel a bit lost. I'm going to go over that again now. Are we all okay with the x plus 2 bracket? Right? We're testing. We get that -2 works. To get x equals -2 from the bracket, we have to have x plus 2. Right? It's always going to have the different sign there. Then, to get your second bracket, you say, what must you multiply the first term by to get that first term? It's x squared, right? Because x times x squared is x2. Then you look at your last term. What must you multiply 2 by to get 24? 12, all right? Then I always look at the x squared terms, all right? I'll show you now that it does work for the x as well. But I think it's easiest to look at the x squared term. My x squared term is 9x squared. So if you take your constant value here, your second term in the binomial, multiply it by the x squared in the trinomial, you're going to get 2x squared. So we need another 7x squared, right, to make up the 9x squared. The only other product from our binomial and our trinomial that will give us an x squared term is the x and the x. Right? If I multiply an x term by another x term, I get an x squared term. So to get x, what does I multiply x by to get 7x squared? 7. All right, we're going to do more examples now, right? Don't worry. So that is how I got that 7. Now, what is this? A trinomial. Can I factorize that one? X squared plus 7x plus 12. 6 and 1. So 6 and 1 gives me 12. 4 and 3, yes, correct. This is how I trinomial that we have to factorize. Okay, factors of 12. The sum of those factors is 7. All right, so we're going to say x plus 4 and x plus 3 equal to 0. And guys, I'm purposely going over factorizing trinomials again because you're going to have to do it when you're going to. Right, you're not allowed a calculator, so you probably won't be able to use the quadratic formula. So we need to recap how to factorize trinomials. Okay. Now from this, I'm going to get an x value from each of these 3 brackets. What's the x value that I get from the first one? -2. That's the first one that we actually got, right? Using our trial and error, but now we need to write it down. From my second bracket, if I make x plus 4 equal to 0 and move that plus 4 over, it's going to be -4, right? And from my third bracket, if I make x plus 3 equal to 0 and move the plus 3 over, it's going to become -3. Okay, that's it. Those are all the stories. Yes. I suppose that, yeah, I suppose they. The thing is, yeah, so they might say you have to use remainder and factor theorem, which I'll still explain, but I mean, yeah, it also is a trial error. It's just they might not always be nice answers like this. It might be like a 12 or something, then it will take you ages. Okay, guys, any other questions on this one? We are going to do another one now. Maybe going to practice some on your own. What is the time? Oh, 5 minutes. Okay, can I give you one to just try on your own? Okay, and then that's kind of like your homework, but you can do it now in class. Then we'll practice some more tomorrow. Just see if you can manage it on your own. Okay, we have x cubed plus 2x squared minus 5x minus 6 equal to 0. Right, I want you guys to solve for x in that one. Yes, you will. Yeah. Yeah. Yeah, don't do that. All right, I'll see you guys tomorrow. Week B, choose that, and see you guys. We'll do that on Wednesday. Okay, do that now quickly, guys. You can finish it still in the 4 minutes that are left. You multiply the binomial terms together and change the sign. Oh, wait, let me just stop here, sorry.